Hello students, we will begin with the next content of the chapter Motion in a Straight Line. In the previous lecture we have learnt about speed, velocity and its types. So further, the important variables which occur in this chapter will be dealt with. So whenever we are moving in a vehicle, if you go with your bike or scooty, we have a apparatus being fitted over there which will show a pointer. That pointer will move or deflect, okay, and will show different values at different instants. If you are accelerating faster, the pointer will read a higher value, and if you slow up, when you apply the brake, what will happen to the pointer? The pointer will come down and it will show some minimum value. So that apparatus is called as basically called as what? Speedometer, which will give you the value of speed, okay, at a given instant. It will not provide the value for average value of velocity, but it will give you the velocity or speed of the object at that particular instant of time. So what is meant by this instantaneous speed and instantaneous velocity? How do we represent them? That we will study today. So instantaneous speed, it is nothing but speed of the object or a particular body at a particular instant of time. At 4th second, at 5th second, at 1 hour. Okay, at particular time interval, how fast or how slow the object is moving. That will be represented by what? Instantaneous value for speed. So instantaneous speed can be defined in this way, that is speed of an object at particular instant. At what? Particular instant of time. So here the interval for the time will be equal to 0. Means when we are checking the value for average, we have seen that we calculate the value for average speed as in within 5 minutes. What is the speed being travelled by the object? So duration was 5 minutes. If you reduce down for 2 minutes, what is the duration? So this delta t in the cases will be 5 minutes, 2 minutes. It may get down reduces to seconds. Okay, 20 seconds, 10 seconds, 1 second. And sometimes the interval for time will be very short, infinitely small, that it may be equal to 0. And at that interval, or at that instant when there is no change in the time occurred, means at a particular instant, what is the speed attained by the object. Okay, so to represent these values, we are using one type of variable that is called as a limit. So whenever I am applying limit to distance, so in this case I have taken x is the notation for measuring what? Representing a distance. So to measure your distance, when I apply limit value, I am getting velocity. Now here it is a speed, and that speed is instantaneous. So I have used the notation inst, okay, at the word. So V inst will give you the instantaneous speed value. It is given by limit of delta t tending to 0. So this will give you a coefficient, that is a limiting coefficient. So when I apply limiting coefficient to something, I will get a value, okay, which is very, very small. So when I apply this to delta x, which is your change in distance, okay, with respect to time. So when this time interval will get equivalent to almost 0, I am getting a value. Okay, so when I apply limit to something, I am obtaining a differential value of that given variable. So d upon dt, that is a differentiation of x, which is the distance, differentiation of distance which is depending upon time t. So the dependent variable will be at the denominator, okay, sorry, here x numerator, and independent variable will be at the denominator. So t doesn't depend upon x, whereas x it depends upon t. So differentiation of x with respect to differentiation of t will give you the value or numerical formula for measurement of what? Instantaneous speed. So here your dx and dt, they are infinitesimal values. So what is meant by infinitesimal? These are nothing but very small values. Very small values of what? Delta x and delta t. So I have used the word that is speedometer. So speedometer, it is a device which will measure the value for what? Instantaneous speed. So how do we represent it? If it is a velocity, so instantaneous velocity, similar formula, only the change is instead of considering the distance, I need to take what displacement made by the object. So it is nothing but velocity of the object again at a particular instant of time. So what is the velocity attained by the object at a particular 5th second, 10th second? What is the velocity? That is called as what? Instantaneous velocity. So again it is numerically represented like this. V bar. I have already told that this bar notation or arrow mark above the variable represents that the variable is a vector quantity. Vector is something which has magnitude as well as direction. So V bar, that is instantaneous velocity, is equal to, again you need to apply limit for change in displacement with respect to time, that is delta x bar. It indicates that this is a displacement. It is also a vector quantity, therefore x bar upon delta of t. So when I apply limit to this quantity, I am getting a differential variable for displacement, that is d of x to dt. And this is giving you the formula for what? Instantaneous velocity. So one more important point, that is these two quantities, they are found to be equal to one another. Means their magnitude will be equal to each other. Let us take example here. I have drawn a plot for position being taken along the y-axis and the time of the object will be taken along the x-axis. O is the reference point, means with respect to O, I am going to find out the value for instantaneous speed or instantaneous velocity. So if you want to find out average, what we have done, we have drawn a triangle for this curve and we have obtained the value for average speed and average velocity. But when we go across instantaneous values, we need the value for instant of time. So let us take example for, I want to find out what is the speed attained by the object at 2 seconds, means the time is 2 seconds. At that instant, what is the velocity the object will have? How do I obtain? It is nothing but you have to draw perpendicular over the curve and from this again draw perpendicular which will cut your y-axis. So it is roughly equivalent to how much? 8. Okay. So 8 upon 2 will give you the value for its instantaneous speed or instantaneous velocity. That's the point here. So here 8 divided by 2, okay, will give you the value numerically. I am saying it is so much, that is 4 meter per second. Means when the time is 2 seconds, the object had attained a speed of how much? 4 meter per second. It is equivalent to how much? 4 meter per second. And if you want to find out these values graphically, how do I do it? So if it is a curve, I want to find the value here. Okay, this is the average. Already I have talked about, we will draw a straight line like this, then we will plot a triangle and then we will take this value which is your y component, similarly x component values, take the ratio of y component to x component, you will get the value for what? Speed or velocity. Now here we do not require that change in value, that is displacement upon time or change in the position of the object with respect to time. I want the value for a particular instant, so at this instant. So how do I get? Your line will become shorter. So here delta t is this much, 3 minus 1, it is 2 seconds, and I draw a line here. This is the reading for delta t. But in this case for instantaneous value, your change in time should be equivalent to 0. Means at this point, if you draw here, your delta t in this case should be equal to how much? Almost equal to 0. So then defined for instantaneous variables. Is the point clear? Now, whenever we think about change in the position or displacement, we have measured a physical quantity, that is a velocity. But certain cases what will happen, the velocity will also changes with respect to time. And then we need to use one more variable, that is called as what? Acceleration. So acceleration, it is nothing but rate of change of velocity. At what rate the velocity of the object is changing. So when we take into consideration this thing, that is change in the velocity, we have a variable for what? Acceleration, and it is defined in this manner: rate of change of velocity. Which quantity is changing now? Velocity of the object is changing with respect to time. So it will give you how fast the velocity changes. When do I measure it? I will say that I am calculating acceleration of the object. So if you apply, if you use the steering and if you increase acceleration, then what will happen? The speed of the object will increase abruptly. So in that case, the velocity is changing, then we will use that I have accelerated the bike or the vehicle. So that term indicates that there is a change in which variable occurring? Velocity of the object is changing with the time. So when the velocity changes with respect to time, that variable is termed as what? Acceleration. So acceleration is mathematically represented. Again, it is a vector quantity as it contains what? Velocity term, which is a vector. So therefore a bar, again acceleration is a vector quantity. So acceleration is equivalent to change in velocity with respect to what? Time. So ratio of change in velocity to time will give you acceleration. So change in the velocity, V1 is the initial velocity, V2 is the final velocity, and difference of this, that is V2 minus V1 will give you change in the velocity. And if you want to find out time, it is again change in the time, that T2 minus T1. Initial time T1, final time T2. So T2 minus T1 will give you change in time represented by delta T. Change in velocity will be represented by delta V bar. So this is the formula, delta V bar upon delta T, which will give you acceleration of the object. It will give you what? Acceleration of the object. Similar to your velocities and speed, we have seen its types. Here also for acceleration we have again two types. One is the uniform acceleration. Uniform acceleration means acceleration of the object is remaining constant. Or other way you can say that when the object is said to be accelerated, it is depending upon mainly a variable velocity. So if the velocity changes by equal amount in equal interval of time, then the object will said to have uniform acceleration. Means the time is changing by 1 second. Velocity is also varying by, let us take example, at the beginning it is 0, then 2 meter per second, then 4 meter, 6 meter per second, 8 meter per second. So here in the time interval which is changing by 1 second, the velocity is also changing by how much magnitude? 2 meter per second. So if the velocity is also changing by equal magnitude in equal interval of time, then the object is said to have uniform acceleration. It is said to have what? Uniform acceleration. Therefore it is defined in this manner. Uniform acceleration is change in what? Velocity by equal amounts in equal interval of time. So these two quantities, that is velocity as well as time, they are changing by same magnitude. Okay, so you can define it in this manner, or you can define it other way, that is if the object's acceleration is remaining constant throughout the motion of the object, then we can define that acceleration to be uniform acceleration. Either way you can define the term what? Uniform acceleration. In certain cases the velocity may not change by equal amount, then we need to define the second type, that is called as non-uniform acceleration. So non-uniform means again the acceleration is not remaining constant throughout the motion, or the variable here is velocity. So velocity is not changing by equal amount throughout the motion in that equal interval of time. So if your velocity changes by unequal magnitude, unequal amount, okay, wherein your time is changing by equal magnitude, then the acceleration attained by the object is said to be as non-uniform acceleration. Acceleration is said to be as what? Non-uniform acceleration. So here acceleration, it basically depends upon velocity as well as time. So when these two quantities, velocity and time, they interdepend upon each other, we have defined the term what? Acceleration. So uniform is your acceleration remains constant. Non-uniform is the one wherein acceleration changes. Okay. So we have one more term related with it, that is whenever your acceleration varies. Okay, we need to define average acceleration. So average acceleration is defined as a ratio of two quantities, that is total change in the velocity to total time taken by the object. When I take ratio, that is change in the velocity divided by total time taken, I will get what? The value for average acceleration attained by the given object. Similarly, your instantaneous value for acceleration means acceleration attained by the object at one particular instant of time can be defined by again taking the limiting value for change in a velocity with the time. It is defined as acceleration of the object at a particular instant. At a particular instant. So, instantaneous acceleration is equivalent to limit of delta t tending to 0. Again, your time change in the time is equivalent to 0. So when I apply limit to this, I am getting again a differential component, that is dv upon dt. So dv upon dt will give you the value for instantaneous acceleration. So it is a vector, so therefore a bar, v is the velocity which is again a vector, therefore v bar. So dv bar upon dt will give you the value for a bar acceleration. Okay, acceleration at a given instant. Sometimes you need to represent the same acceleration in terms of what? Displacement. So how do we represent it? Again by using the differential formula. So dv upon dt. Velocity, we know that it is nothing but a rate of change of displacement. And mathematically, how do I write? It is a dx upon dt. So when I write or replace this v by dx upon dt, differentiate it double time. So d square upon dt square is again represents acceleration, but here the independent variable, it is time, and the dependent variable is what? Displacement. Here independent variable is time, whereas dependent variable here is velocity. So this is called as a first derivative for velocity. First, because here you have d to the power how much? 1. Whereas this is called as second derivative of displacement, because d to the power we have what? 2. So when I differentiate the displacement 2 times, I will attain acceleration. In further classes, we will let you know how do I differentiate a quantity. Just now we will see the theoretical part of it. That is, whenever I differentiate any quantity, I will obtain a new variable. Now here, once if you differentiate, you are getting, that is velocity. When you differentiate, you are getting acceleration. If you differentiate it twice, you are getting again the acceleration. But here, the differential variable is displacement. Okay. Then we will see some graphical representation of it. Already we have talked about change in the velocity with the time, and we have seen how you are getting uniform velocity, non-uniform velocity. In the similar manner, just now we have seen your displacement, it depends upon acceleration. So how do I represent this? Okay, so it is again used by position time graph. It is also called as PT graph. It is called as what? PT graph. Okay, here I have taken position or displacement of the object along the y-axis, and time is taken along the x-axis. So when your x is changing with respect to time, Then this is the representation for positive acceleration. Your position of the object is continuously changing, okay, with respect to time. Whereas here, this is the representation for negative acceleration. You will get a curve like this, okay, which is opened up in the downward direction. And in certain cases, your acceleration will become zero. This is the case when the object's velocity remains constant. Object's what? Velocity is constant. So when velocity is constant, the acceleration will automatically become zero. Why? Because acceleration, it is defined as change in velocity. So when there is no change in the velocity, we cannot define the term what? Acceleration. So when velocity term it becomes constant, automatically your acceleration will be equal to 0. It is equal to what? 0. So here this is the representation for uniform velocity. Your velocity change in the velocity is constant. Therefore your acceleration will become 0. Okay. Now here the velocity time graphs, wherein I have taken velocity along the y-axis and time has been taken along the x-axis. When object had begun its journey, let us consider that v0 is its initial velocity when I have started measuring it with respect to the reference point O. So the object's velocity is increasing. So along again a positive direction. When the velocity is increasing along a positive direction, your acceleration will be equivalent to 0. We know that whenever object need to move, we need to apply the force. So let us take the example that object is moving along this direction. Along the same direction, if I apply the force, if I accelerate the object, then what will happen? The object will move faster. So then we will say that the acceleration of the object has increased. So whenever there is change in the velocity in a positive way, or when the velocity of the object increases, then the objects will said to have positive acceleration. One more example we will take. Object is freely falling under the effect of gravity. Object is there, I have thrown it or left the object like this. The object will move in the downward direction. Now it is under the effect of force. The object's direction of motion is like this. The force of the gravity is also acting in the downward direction. Okay, we have studied about the gravitational force already. So direction of gravitational forces, it always tries to pull the object towards itself. So this is the direction of force being acted upon by the earth on the object. So direction of force, the object is moving in the same direction. In that case, the acceleration attained by the object will be a positive quantity. In the other example, we will take object which has been thrown in the upward direction. I have thrown the object above. So what will happen to the velocity? Velocity, when I throw it, will have maximum value. It will slowly decreases as the object will move. It will reach certain height, then automatically the velocity will become 0. When the velocity becomes 0, the object will again come back. So the upper case we will take here. The force of gravity is in the downward direction, and the object is moving in the opposite direction. So in that case, the acceleration of the object is negative. So how do I represent it? The object will have maximum velocity. Then slowly the velocity decreases. So here the acceleration is negative. Another example is the object's velocity is moving in a negative direction. The object motion is again taken along the negative direction. Then also the acceleration will become a negative. So these are the representation for position time graph, pt graph, velocity time graph, vt graph. One important point related with this graph, it is if you want to find out displacement graphically, I can obtain the value for displacement graphically just by taking area of the graph which is drawn below the line. Okay, between velocity and time curve, what is the area covered? If you calculate that much, you will obtain the value for displacement. Now take the example for this. This is the line, and if you draw here like this, this is velocity and time curve, and this area, if you find out, It is a trapezium structure, isn't it? Apply the formula for trapezium, automatically you will get the value for displacement attained by the object. Here also, this is the graph, this is your trapezium, obtain its value, automatically you will get the value for acceleration, displacement of the object.